This 2-hour block of Revisewise programmes is about maths. After a short introduction to the key Stage 2 national test papers, it covers number and place value, fractions, percentages, addition, subtraction, multiplication, division, and how to use a calculator. The starting time for each programme is shown on the menu, so they can be found by using the clock in the top right-hand corner of the screen. First, number and place value.
Hello, I'm here to help our puzzling pupil and you to make the most of what you know when you come to do your key Stage 2 maths tests. In each of these programs, as well as in our books, audio tapes and on the internet, we'll be looking at the bits of maths you might find tricky. So, what's the problem?
I've got my maths test paper here and I'm not quite sure what to do.
Let's have a look. Aha, yes. This is just one of the 2 maths test papers that all Year 6s will be doing in May. And there's a paper A and a paper B, and in each paper there'll be questions about all the maths that you've learnt at school. Now, the people who've set these questions aren't out to trick you. They just want to know what you know. In fact, you need only get slightly more than half the questions right, and you'll get a level 4. And that's the standard everyone is hoping you'll get at the end of primary school.
You said there are 2 maths papers. What's the difference between them?
Well, both papers cover all the maths, but in the second paper, that's paper B, you can use a calculator. And in the first one, paper A, you can't. But what exactly happens on the day of the maths test?
Preparations for the test start well before the pupils arrive. The teacher has to cover any maths displays on the classroom wall. Next, the tables and chairs are moved so pupils can't see each other's work. Then she lays out all the maths equipment needed for the test.
Right, this is the equipment they need to have. Each child needs to have access to a mirror, tracing paper, an angle measurer. Some children prefer one type over another. Sharp pencil and a ruler showing centimetres and millimetres.
It's time for their first maths test. So, this Year 6 class is let into its classroom.
Right, sit down quietly, roughly where you would normally sit. Now, has everyone got all of the equipment they need for this morning?
The head teacher brings in the test papers in their sealed bags.
I'm going to send around the paper. Don't open it, but on the front you can write your first name, last name, and then the school, which I've written on the blackboard for you. So take one each and then pass them on. This is paper A. You are not allowed to use a calculator, Stephen, for this paper. You are not allowed to talk to other people in the room when you're doing this test. All the work in the booklet must be your own work, so you're not allowed to copy someone else's work. Does everyone understand that? It must be your work. Thank you. For this paper, you will have 45 minutes. Right, you may open to question 1 and begin.
Once the test starts, it's all down to them.
So, is that it then?
Not quite. There's also a short mental maths test. So what's all that about?
Here is the practice question to show you what to do. What is 6?
In the mental maths test, you listen to the questions played from a tape.
What is 6 less than 25?
You work out the answers in your head and write them down on the paper.
Question 1. How many 20-pence pieces are there in £2?
The finished test papers aren't marked by your teachers. They're sent off to be marked by other teachers who don't know you or your school.
So, there they are.
The people marking the tests add up all the marks from your 3 papers. Paper A, Paper B, and your mental maths. And that's what gives you your level, level 4, we hope. So if you don't do well on one paper, you could do better on another and still get your level 4. Of course, how you get on in your test is up to you. But one thing is certain. If you've prepared well, then you'll do well. And that's what we're here to help you with.
I've got my pencil, my ruler, my angle measure, my mirror, and my tracing paper. I'm ready to get stuck in.
No, don't just dive in straight away. You've got 45 minutes, that's 3/4 of an hour for each paper. So there's plenty of time to read all the questions first and check the answers. So let's look inside a real test paper. In each paper there are about 20 questions. They start with the easier ones first, and they get more difficult as you go on. Now, some things you can do in your head, and some things you'll need to write down. One thing worth knowing is that all the questions on the different parts of maths you've done at school are mixed up throughout the paper. Here's one on number work. Here's one on recognizing shapes. And here's one on graphs and charts. Allow between 1 and 2 minutes for each question. And if you get stuck on a question you can't do straight away, it's worth going on to the next one because it might be about something completely different that you can do. So, let's make a start with some real maths test questions.
Use all the digits 6, 1 and 3 to write a number that is between 100 and 140.
Now that's a good question to start. It's about the number system. But before we have a go at it, let's remind ourselves what we know about number and place value. Over to our maths team.
Units,
Tens,
hundreds,
thousands, 10,000s,
100,000s, millions.
All these digits are the same. They're all 2s. But they mean something different depending what place they're in. When it's there, it means 2. When it's there, it means 20. There, 200. 2,000, 20,000, 200,000, and 2 million. Watch how these numbers get bigger and bigger. What do we call a big number like this? Over to our maths team.
This number is 868. It's made up of 800s, 60 and 8.
So what's this big number called?
This number is 26,243. It's made of 26,200s, 4 tens and 3 units.
So let's go back to your test question.
Use all the digits 6, 1 and 3 to make a number between 100 and 140. With those digits, I can make 613, but that's too big to be between 100 and 140, so is 631. I can make 361 and 316, but they're too big as well. So that leaves 163, that's too big, and 136, which is between 100 and 140.
Well done. So put it in the box. Now, what happens when you multiply a number by 10?
This number is 32. It is made up of 3 tens and 2 units. When it is multiplied by 10, the 2 digits move 1 place to the left, and where the 2 units were, a 0 fills their place.
So, when you multiply a number by 10, the digits move 1 place to the left, and you put a 0 in the space. And when you multiply a number by 100, the digits move 2 places to the left, and you put 2 zeros in the space. And when you multiply a number by 1,000, the digits move 3 places to the left, and you put 3 zeros in the space. And multiplying by 1,000 is equivalent to multiplying by 10, and then by 10 again, and then by 10 again. When you divide a number by 10, the digits move 1 place to the right. And when you divide a number by 100, the digits move 2 places to the right. And when you divide a number by 1,000, the digits move 3 places to the right. This works exactly the same way with decimal numbers. When you multiply by 10, the digits move 1 place to the left. When you divide by 10, the digits move 1 place to the right. The decimal point stays where it is. How can we use what we know about place value to sort big numbers into order, like these two? Over to our maths team.
To see which is the biggest number, first you look at the thousands, then the hundreds, then the tens, then the units. But on this one has 7 thousands each, 200s each, and this one has 6 tens, and that one has only 1, so it makes this one the biggest.
Let's try another one, this time with some decimal numbers. Put these numbers in order. At a glance, the 985 may appear bigger than the 463, but look carefully at their place value and where the decimal point is. It's a good idea to write the numbers underneath each other, and even to write in the missing zeros as well. Then you can see that 463 has 4 hundreds and the others have no hundreds, so 463 must be the largest number. 78.3 has 7 tens and the others have none, so 78.3 is the next largest. 8.35 has 8 units, while 0.985 has none, so 8.35 is the next largest, and 0.985 is the smallest. That's the end of our unit on number and place value. So let's check what we've done. We saw what happens on the day of the maths test. We looked at the number system and place value. We saw what happens when you multiply and divide numbers by 10. And we worked out what big numbers are called and how to put them in order. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the programme again. There are also books, a maths audio tape, and our interactive Revisewise website to help you make the most of what you know when you're preparing for your test. So we'll let you get on with your test, and you get on with your television revision.
The next program is about fractions.
Hello, I'm here to help you and our puzzling pupil make the most of what you know when you do your Key Stage 2 maths tests. In each of these programs and in our books, audio tapes and on the internet, we're looking at the maths you might find tricky. This time, it's fractions. So, what's the problem?
I'm a bit stuck on this question.
Well, let's hear it then.
Draw one line to join two fractions which have the same value.
Fractions are something we can all have trouble with. So what does our maths team have to say about them?
This is 1/3. A whole has been split into 3 equal parts. You have one of those equal parts. This is 1/8. A whole has been split into 8 equal parts. You have one of those 8 equal parts. This is 1/20. A whole has been split into 20 equal parts. You have one of those 20 equal parts.
1/3 of a pizza means that one whole pizza has been split into 3 equal parts. And we have one of them. 1/8 of a pizza means that one whole pizza has been split into 8 equal parts. And we have one of them. 1/20 of a pizza means that one whole pizza has been split into 20 equal parts. And we have one of them.
The bottom number of a fraction is called the denominator. It tells you how many equal parts the whole has been split into.
To put these fractions in order, you have to look at the denominator. The bigger the denominator, the smaller the fraction would be. So 1/20 is the smallest fraction.
Now that's a really useful thing to remember. The bigger the denominator, that's the number on the bottom, the smaller the fraction. 1/3 of a pizza is a big chunk because there are only 3 of them in the whole pizza. 1/20 of a pizza is only a small slice because there are 20 of them in the whole pizza. The top number of a fraction is called the numerator, and it tells you how many equal parts of the whole have been taken. So, for example, 2/3 means that the whole has been split into 3 equal parts, and we have 2 of those parts. More from the maths team.
These are the denominators. They show you how many equal parts a whole has been split into. These are the numerators. They show you how many of those equal parts you have.
Some fractions look different, but are worth the same. They have the same value. They're called equivalent fractions. The maths team explains.
Fractions can be equivalent. Like 1/4 is the same as 2/8. And 1/4 is also equivalent to 4/16.
Look at these equivalent fractions. 2/3 is equivalent to 4/6, and it's also equivalent to 6/9 and 8/12. See if you can spot the equivalent fractions before Mathman does.
Mathman, your mission is to eat only fractions equal to 1/3. When you come to a number, you will have until a count of 3 to make your decision, and beware the obstreperous Mr. Glitch. He will eat you if you are wrong.
Yep. Mathman, 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 Mathman. Yep. 1/3. I still got it. Mathman, 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 Mathman. That's 1/3. Right again. math man, math man, 1/3, 1/3, math man, math man, math man, math man, math man, math man.
Hard enough.
Use your head. Nope.
Oh,
Math man, 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 math man. Math man, math man.
How can we check if two fractions are equivalent? One way is to multiply the numerator and denominator of one fraction by the same number and see if you get the other fraction. Let's see if it works. Is 3/4 equivalent to 6/8? The denominator of 3/4 is 4. Multiply it by 2 and the denominator becomes 8. The numerator of 3/4 is 3. Multiply it by 2 as well, and the numerator becomes 6. So 3/4 is equivalent to 6/8. There's another way you can check if fractions are equivalent. You can divide the numerator and denominator of one of the fractions by the same number and see if you get the other fraction. Is 12/16 equivalent to 6/8? The denominator of 12/16 is 16. Divide it by 2 and the denominator becomes 8. The numerator of 12/16 is 12. Divide it by 2 as well and the numerator becomes 6. So 12/16 is equivalent to 6/8. Dividing the numerator and denominator by the same number like this to make them as small as you can is called simplifying a fraction. Let's simplify 12/16. What number can we divide both the numerator and the denominator by? Try 2. 2 into 12 is 6, and 2 into 16 is 8. So 12/16 simplifies to 6/8. Can we simplify further than this? Try 2 again. 2 into 6 is 3, and 2 into 8 is 4. So 12/16 simplifies to 3/4. And that's as far as we can go. Now, does that help you answer the question?
Well, let's see. They're all different fractions, but the question says I've got to look for two fractions that have the same value. So, am I looking for two equivalent fractions?
That's right.
So I'm looking for a fraction that I can simplify by dividing the numerator and the denominator by the same number.
Yeah, go on.
Well, let's see. It's 2/8.
Yeah, but why?
Because I can divide both the numerator and the denominator by 2. 2 into 8 is 4, and 2 into 2 is 1. So 2/8 becomes 1/4. So that's the answer.
Yeah, now is it? What exactly does the question ask you?
Draw one line to join two fractions which have the same value. Oh, I see. I have to draw a line from the 2/8 to a 1/4, like this. Like so.
Exactly. It's really important, once you've done the maths, to check the question again to be sure you've actually answered what it asked you.
Look, here's another question about fractions. It says, place these fractions in order of size, starting with the smallest. Then it's got 1/2, 1/3, 5/12, and 5/6.
It's an interesting question. Go on, have a go.
Now I know that 1/3 is smaller than 1/2.
Why?
Because there are more thirds in a whole than there are halves. So they must be smaller.
And something else that we learned?
Oh yes, the bigger the denominator, the smaller the fraction. But it's hard to tell about the others. They're all different fractions.
I think equivalent fractions are going to help here.
I've got it. What if I change each fraction so they all have the same denominator? Then I can compare them properly.
You're on the right track. So what denominator could you change all these fractions to? And remember, it must be the same denominator for all the fractions.
How about 12ths?
Try it.
Right. With the 1/2, I have to multiply the denominator by 6 to get 12ths. So I multiply the numerator by 6 to get 6/12ths. With the 1/3, I multiply the denominator by 4 to get 12ths. So I multiply the numerator by 4 to get 4/12ths. The 5/12ths is already a 12th, so I can leave it alone. With the 5/6, I multiply the denominator by 2 to get 12ths and multiply the numerator by 2 to get 10/12ths. So that's it. The smallest is 4/12ths, the next is 5/12ths, the next is 6/12ths, and the biggest is 10/12ths. Done it!
But have you? Once you've done the maths, check what the question is asking.
Oh, I have to write the original fractions in the boxes, like this.
Yes, that was a close thing, and after all that work, so it really is important to read the question. Another kind of question you might get is to find the fraction of another number, or a length, or a quantity of money. Like, what's 3/4 of 24 centimetres? First of all, divide the 24 centimetres by the denominator to find 1/4 of 24 centimetres. 24 centimetres divided by 4, that's 6 centimetres. Then multiply the answer by the numerator, that's 3. 6 centimetres times 3 is 18 centimetres. So 3/4 of 24 centimetres is 18 centimetres. So to find the fraction of a quantity, divide by the denominator and then multiply by the numerator. Finally, fractions can also be written as their equivalent decimal. That's the decimal number that has the same value as the fraction. Over to our maths team.
A half is equivalent to 0.5.
1/4 is equivalent to 0.25.
3/4 is equivalent to 0.75.
1/10 is equivalent to 0.1.
2/10 is equivalent to 0.2.
3/10 is equivalent to 0.3.
See if you can spot all the numbers less than 1/2 before Mathman does.
Mathman, 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 Mathman. That's less. Too smart. Mathman, 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 less than 0.5. Mathman, 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 Mathman. That's less too. Yeah! Less than 0.5. Mathman, 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 Mathman.
Wow.
Must be less. Rats.
That's the end of our unit on fractions. So what did we learn? We saw that fractions are parts of a whole. We looked at equivalent fractions and how to simplify fractions. We put fractions in order and we looked at the decimal equivalents of fractions. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the programme again. There are also books, a maths audio tape, and our interactive Revisewise website to help you prepare.
The next programme is about percentages.
In these programs and in our books, audio tapes and on the internet, we're helping you with the things you might find tricky in your Key Stage 2 maths tests. This time, it's percentages. So, what's the problem?
I'm a bit stuck on this question. Calculate 24% of 525.
Before we have a go at that, let's do some television revision and remind ourselves about percentages. Over to our maths team.
Percent means out of 100.
1% is equivalent to 1 out of 100.
2% is equivalent to 2 out of 100.
4% is equivalent to 4 out of 100.
5% is equivalent to 5 out of 100.
Percent means out of 100. So 1% means 1 part out of 100 equal parts. If you think of 1% as a fraction, it's 1/100th, and this sign is a short way of writing it. So 10% means 10 out of 100. 25% means 25 out of 100. 50% means 50 out of 100. Percentages and fractions are all closely related. Over to the maths team.
50% is also equivalent to a half.
25% is equivalent to 1/4.
75% is equivalent to 3/4.
10% is equivalent to 1/10.
20% is equivalent to 2/10.
If you don't know these, you can work them out. Remember, percentages are fractions with a denominator of 100. That means that 1% is the same as 1/100th. So 25% is the same as 25/100ths. Simplify this fraction by dividing the top and bottom by the same amount. Let's try 5. 5 into 25 is 5, and 5 into 100 is 20. Divide by 5 again. 5 into 5 is 1, and 5 into 20 is 4, which makes it 1/4. That's 1/4. So 25% is the same as 1/4. To change a fraction into a percentage, change it into an equivalent fraction with 100 as the denominator. Let's check that by turning 1/2 into a percentage. We want to turn it into an equivalent fraction with 100 as the denominator. To turn the denominator 2 into 100, multiply it by 50. Multiply the numerator by 50 as well. 1 times 50 is 50. So 1/2 is equivalent to 50/100ths, that's 50%. See if you can spot all the percentages less than a half before Mathman does.
Mathman, 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 Mathman. Less than 1/2. Mathman, Mathman, Mathman. Less than 1/2. Mathman, 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 Mathman. Pretty small. All right. Mathman, 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 Mathman. Tough call. Yep. Oh!
Does this help you with your question?
Well, I know that 24% of 525 means 24/100ths of 525. And I know that the word of means multiplied by. But what's the best way to work it out?
Okay, let's run through how to work out percentages of whole numbers. How about 40% of 200? First, change the percent into a fraction. That's 40/100ths. Simplify the fraction by dividing the top and bottom by, say, 10. That gives us 4/10ths. Work out 4/10ths of 200. Divide the 200 by the 10, that's 20, and multiply the 20 by the 4, that's 80. So 40% of 200 is 80. Another way to answer this is to use number facts that you already know. We know that 10% of 200 is the same as 1/10 of 200. That's 200 divided by 10. Move the digits 1 to the right, that's 20. 40% is 4 times that, which is 80. So, 40% of 200 is 80. If you remember the well-known percentages and their fraction equivalents, they'll help you work out more difficult percentages, like our maths team are doing.
To find 30% of £5, I would divide by 10 to find 10%, and then times it by 3, which would make 30%. Altogether, it'd become £1.50.
I think I'm ready to have a go at this question now.
Okay.
Let's see. I know that 10% of 525 is the same as 1/10 of 525, which is 52.5. 20% is twice that, which is 105. Now, 1% of 525 is 1/10 of 10%, which is 52.5 divided by 10, which is 5.25. 4% is 4 times that, which is 4 times 5.25, which is 21. I add my answers for 20% and the 4% together, so that's 105 plus 21 equals 126. So 24% of 525 is 126.
So write it in the box to get the mark. In fact, this question is on the maths paper B, so you're allowed to use your calculator, which is always useful with big and awkward numbers. Okay, so 24% is 24 over 100. Multiply 525 by 24 and divide by 100. That's 525 times 24 divided by 100 equals 126 again. To change a percentage into a decimal, divide it by 100. So 50% is the same as 0.5. 25% is the same as 0.25. 75% is the same as 0.75. Can you see the pattern? So, what's 12%? %12 is 0.12. And 8%? %8 is 0.08. Watch for the place value. But how are percentages actually used?
You often see percentages advertising how much extra you're getting, or how much is taken off the full price.
You're quite likely to get questions in the test about percentages used in shopping, like discount, profit and loss.
Here's one. In a sale, a shop reduces the price of a jumper costing £40 by 5%. What is its reduced price?
Yes, that's a good one.
And I can do that. To get 5% of £40, I know that 10% of 40 is £4, so 5% is half that, which is £2. So that's the answer.
Now, is it? Read exactly what the question is asking.
What is its reduced price?
Yes.
Oh, I see. I've worked out how much they've reduced the price by. I need to take that away from the full price to get the reduced price.
Exactly.
That's £40, take away £2, which is £38.
Write the answer in the box. If you get a question like this in your test, check exactly what they're asking. Is it a percentage off or a percentage added on? Look for words like discount, profit, loss, reduced price, increased price. Another use of percentages is to show one amount as a proportion of another.
90% of injuries, 90% of internet users, and 35% of children have mobile phones.
Now, that doesn't tell us exactly how many children have mobile phones, but it does give us a good idea of what proportion of children have them. Try this question. In a maths test, my score was 48 marks out of 60. What did I get as a percentage? First thing to do is make a fraction with my marks on top as the numerator and the total marks on the bottom as the denominator. Now, getting this fraction the right way round is really important when you're working with percentages. It's the total, the amount out of, that goes on the bottom. So the fraction we're after is my marks, 48, over the total marks out of, which is 60. First, simplify the fraction by dividing the top and bottom by 12 to make it 4/5. To turn the 4/5 into a percentage, multiply it by 100. That's 4 times 100, 400, divided by 5, which is 80%. Not bad for a maths test. The advantage of turning things into percentages is that they can easily be compared with each other. Let's say that in my next maths test, I scored 20 marks out of 25. Did I do better or worse than in the previous test? You can help with this one. Okay, make the numbers into a fraction. Which way up do they go? My marks on the top and the total marks out of on the bottom. So that's 20 over 25. Next, simplify the fraction by dividing top and bottom by try 5. That makes it 4/5. To turn the fraction into a percentage, multiply by 100. That's 4 times 100, 400, divided by 5, which is 80. So the answer is 80% again. So my maths is staying pretty much the same. That's the end of our unit on percentages. So what did we learn? We saw that percentages are parts of 100. We converted percentages to their equivalent fractions, converted fractions to percentages, and turned percentages into decimals. We looked at different ways of calculating percentages and looked at percentage discounts and profits. Finally, we used percentages to compare different sets of information. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the programme again. There are also books, a maths audio tape, and our interactive Revisewise website to help you prepare.
The next programme is about addition.
In these programs and in our books, audio tapes and website, we're helping you with the things you might find tricky in your Key Stage 2 maths tests. This time, it's addition. Let's start with a real test question.
In the chart, any three numbers in a line, across or down, have a total of 18.45. Write the missing number. And then there are all these numbers in the square. I guess I have to add them up somehow.
You're right, but I think to get this one right, you're going to have to do several different things. Most of the questions on the test paper need a mixture of different math skills. For example, there might be a bit of adding and then a bit of multiplying. Or you might have to look something up on a graph and then do something with the numbers. But in this question, you definitely have to add up some numbers. Adding up numbers is something we do in maths all the time. So let's remind ourselves exactly what it means. Over to our maths team.
Addition means how many altogether.
It also means increase.
It also means plus.
It also means total. It also means sum. It also means more than.
And in everyday life, adding numbers is all around us.
When you go shopping and buy a couple of things, you can add the prices up in your head.
Mine's 49p.
Mine's 55p.
And that makes
£1.4p.
This is 69p. And this is 55p.
When you buy more things, you can write the prices down to add them up.
One. That's a 4. That makes £3.41p.
That's £69.
Another way to add up lots of things is to use a calculator.
£79. That's £3.41, please.
Now, when you're faced with some numbers you want to add up, it's useful to think first, can I do it in my head? Do I need to write it down? Or should I use a calculator? First, some addition sums in your head, some mental addition. How about 59 plus 43? See if you can do it before our maths team does.
To find the answer to 59 at 43, I'd turn the 59 to a 60, then at the end take away 1, and the answer would be 102.
To find the answer to 43 at 59, I'd add 40 at 50, then 3 at 9, and then add the totals together, which will make 102.
Did you notice that Nicola did 59 plus 43 and Sarah did 43 plus 59? But with addition, it doesn't matter which order you do it in. Also, they used different methods to help them get the right answer. Each time, they changed the sum into something that was easier to work out on the way to getting the right answer. Let's look again at what Nicola did.
To find the answer to 59 at 43, I'd turn the 59 to a 60, then at the end take away 1, and the answer would be 102.
What she did was to add 1 to the 59 to round it up to 60. It's easier to add 43 to 60 to make 103, then take the 1 off again to get the right answer, 102. With any number ending in 9, you can add 1 to make the sum easier. With a number ending in 8, add 2 to make the sum easier. And with a number ending in 7, add 3 to make the sum easier. Let's look at the other method that Sarah used.
To find the answer to 43 at 59, I'd add 40 at 50, then 3 at 9, and then add the totals together, which will make 102.
What she did was to split the numbers up and add the 10 separately from the units. 43 and 59 is the same as 40 and 3 and 50 and 9. 50 plus 40 is 90, and 9 plus 3 is 12. Add the two together to get 102. You can practice adding up two-digit numbers in your head. It's something you can do with your friends or at home, like this.
83 plus
19.
102. 42 plus 18.
60. 17 plus 37.
54.
Does this help you with your question?
I'm not sure I can do the adding up in my head, so could I write it down alongside here?
Good idea. When the numbers you want to add up get larger or more difficult, it might be better to use a written method, particularly if the numbers have decimals in them. Over to the maths team.
Stuart's adding 421.36 and 25.7. See how careful he is to make sure he lines up the units under each other, gets the tens under each other, and the hundreds under each other, and lines up the decimal points.
Here's a useful tip when you're doing a written addition. Before you start doing the maths, make an estimate of what you think the answer should be. Try 3.85 plus 16.8. 3.85 is nearly 4, and 16.8 is nearly 17. So the answer is roughly 4 plus 17, and that's 21. Let's see if it is, and watch out in case I make a mistake. 8 and 5 is 13. Put down 3 and carry 1. 8, 6 and 1 is 15. Put down 5 and carry 1. 3, 1 and 1 is 5, so that's 55.3. That can't be right. My estimate was just less than 21. What's gone wrong? I didn't line up the decimal points properly, so my place values were all over the place. I was adding tenths to hundredths and tens to units. That's better. Let's try it again. 5 and 0 is 5. 8 and 8 is 16. Put down the 6 and carry 1. 6 and 3 and 1 is 10. Put down the 0 and carry 1. 1 and 1 is 2. That's 20.65, and that is close to my estimate of 21. So I'm sure it's the right answer.
I think I'm ready to have a go at this question now.
And where you go then?
Right. I've got to find the missing number in the middle of the square. Now, the question tells me that each line in the square must add up to 18.45.
That's right.
If I take the row across the middle, I need to add up the numbers I've got and then take them away from 18.45. So that's 11.07 plus 1.23, which equals 12.30.
Yes, go on.
And I take that away from 18.45 to get 6.15.
And how about checking that answer?
Oh yes, I can add up the line of numbers down the middle of the square to see if they come to 18.45 as well. Let's see. 8.61 plus 3.69 plus 6.15 equals 18.45. So my answer must be right.
There's a third way of adding up numbers, besides doing it in your head or writing it down, and that's to use a calculator. Using a calculator seems really easy. Because it's electronic, it's tempting to think that whatever answer it gives, it must be right. Wrong. The answer a calculator gives you depends on what you tell it when you press the keys. If you tell it the wrong thing by pressing the wrong keys, for example, it will tell you the wrong thing. So make an estimate first. Let's try 2,593 plus 6,078. Make an estimate first. It's a bit more than 2,500 plus 6,000, which is 8,500. Now we can see what the calculator comes up with. First, press the clear key to get rid of any calculations that might be in the calculator already. Then press 2593 plus 6078 equals 8,671, which is close to my estimate of 8,500. The calculator will always give you an answer, but only you can decide if it's right. Take adding money, for example. £3.55 plus £4.75. That's 3.55 plus 4.75 equals 8.3. But is that really the right answer? If it were just numbers, it would be, but it's money, pounds and pence. So we have to write it as 8.30 or £8.30.
Here's a question in the test about adding money. They give you a pizza menu and ask, Jill orders one small cheese pizza with extra tomato. What is the total cost?
Yeah, that's a good one. Let's do it.
Well, I look up the price of a small cheese pizza in the table, which is £3.80, and the extra tomato is 50p. So that's 3.80 plus 0.5, which is 4.30.
Now, is that right? The maths is right, but the question is about money. So what's missing?
Oh, I've missed out the pound sign.
There are lots of questions in the maths papers about money and lengths and weights, so it's important to read the question properly and check that you've given the answer in the right units. And what about the second part of the question for an extra mark?
Ben buys one small pizza and one medium pizza. They cost him £10. Which two could they be?
More addition.
So I'm looking for an amount in the small column and an amount in the medium column that add up to 10. Right, it's £4.50 and £5.50. That's a small mushroom and a medium ham. So I better write that in.
There are often questions like this, where the answer is a word or a sentence instead of a number.
That's the end of our programme on addition. So let's check what we've done. We looked at ways of doing mental addition in our heads and saw how to write down more difficult addition. We saw how to use a calculator to do addition and looked at real-life problems that involve addition. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the programme again. There are also books, a maths audio tape, and our interactive Revisewise website to help you prepare.
The next programme is about subtraction.
To help you with your Key Stage 2 maths tests, in this unit we're going to look at subtraction.
I'm a bit stuck on this question. It says 60 minus something equals 26.
Subtraction. Subtraction is something we do a lot in maths, so let's remind ourselves what it means. Over to our maths team.
Subtract means take away.
It also means decrease. It also means difference between. It also means minus.
It also means less than.
It also means count back.
In everyday life, taking away numbers is all around us.
You use subtraction to work out the right change.
These are 55p. How much change would we get from your pound? It would be 45p.
When you're faced with numbers you want to take away, it's useful to think, can I do it in my head? Do I need to write it down? Or should I use a calculator? First, some subtraction sums in our head, some mental subtraction. 54 subtract 37. See if you can do it before our maths team does.
To work out the answer for 54, subtract 37, I rounded the 37 to 40 and took it away, which was 14. Then I added on the 3, which gave the answer 17.
To get the answer from 54, take away 37. I split the 37 into 7 and 30. I took away the 7 from 54, which I got as 47, and I took away the 30 and I got 17 as my answer.
Although they use different methods to help them get the right answers, they both changed the sum into something easier that they could work out first. Let's look again at what Nicola did.
To work out the answer for 54, subtract 37, I rounded the 37 to 40 and took it away, which was 14. Then I added on the 3, which gave the answer 17.
What she did was to count up in steps from 37 to 54. The first step was from 37 to 40, the nearest 10. That step is 3, which she held in her head. The next step was from 40 to 50, which is 10. And then 50 to 54, which is 4. Adding the steps together gives the answer, 17. While she was doing her subtraction, Nicola was actually doing bits of addition. In fact, addition and subtraction are related, and you can often use addition to help you work out a subtraction. For example, we can check 54 take away 37 equals 17 by adding 37 to the 17 and getting 54 again.
Here are 54 blocks. Take away 37 and you're left with 17. Add the 17 to the 37 and you get 54 again. You can see how addition and subtraction are related if you think about what happens when you buy something and get some change. The shopkeeper subtracts the price of what you buy from the money you give him, and the answer is the change he gives you. So your change is the difference between what you paid and the price of the sweets. What you pay is the sum of the price of the sweets and your change. The price of the sweets is the difference between what you pay and your change.
So how does all this help you answer the question?
Well, they want the number you can take away from 60 that makes 26. I can turn that into 60 equals 26 plus something. Should I use a number line?
Good idea.
That's right. Draw out the number line first and put your numbers on it.
From 26 up to 30 is 4, and from 30 to 60 is 30. So that's 34 altogether.
So write it in the box. Practice subtracting numbers in your head. It's something you can do with your friends or at home.
63 minus 19.
Hmm. 44. 54 minus 11.
43. 100 minus 64.
36.
When the numbers you want to subtract become larger, it's a good idea to draw out a number line for yourself and jot down the steps you've taken along it. Let's try 217 minus 136. The step from 136 to the nearest 10, 140, is 4. The step from 140 to the next nearest 100, 200, is 60. And the final step from 200 to 217 is 17. Add all the steps up together, and the answer is 81. So 217 minus 136 equals 81.
Here's another subtraction question with bigger numbers. Calculate 808 minus 512.
So how are you going to do it?
I could count up from 512 to 808 in my head, or along a number line, but it looks a bit too difficult for that.
You're right. If the numbers have several digits or decimals in them, you'd be better off using a written method. How about 19.27 minus 8.4? First thing to do is make an estimate of what the answer might be. Let's round 19.27 down to 19 and 8.4 down to 8. 19 take away 8 is 11, so that's my estimate. Now back to the proper sum. Write it out in columns with the tens, units and decimals lined up properly underneath each other. 0 from 7 is 7. 4 from 12 is 8. 8 from 8 is 0, and 0 from 1 is 1. So the answer is 10.87. And that's pretty close to my estimate of 11, so my answer's probably right. Now you can try to answer your question.
Okay. Calculate 808 minus 512. So I make an estimate first. 808 is just over 800, and 512 is just over 500. So the answer should be around 800 take away 500, which is 300.
Okay, now do it.
Right. So I write the numbers above each other in lined columns. The units first. 2 from 8 is 6. The tens. 1 from 10 is 9. And then the hundreds. 5 from 7 is 2. So the answer is 296. That's very close to my estimate of 300, so it must be right.
So write it in the box. Now let's not forget the third way of subtracting numbers, and that's using a calculator. Because it's electronic, it's tempting to think that whatever answer a calculator gives, it must be right. Wrong. It depends on what you tell it when you press the keys. If you make a mistake and tell it the wrong thing, it will tell you the wrong thing. Let's try 2,615 minus 1,997. Make an estimate first. That's about 2,600 minus 2,000. Which is 600. What does the calculator come up with? Press the clear key to get rid of any previous calculations. Then 2,615 5 minus 1997 equals 618, which is close to my estimate of 600.
Here's a question or test about subtracting money. They give you the cost of different rides at a fun fair, and you have to work out which ride John could go on and get 80p change from £2.
Right, let's do it.
Well, I have to work out the difference between the money that John's got and the change he'll get back. That's the difference between £2 and 80p. That's £1.20.
Well, the maths is right, but what does the question ask?
Ah, it asks which ride John went on, so I have to look up the one that cost £1.20. That's the big wheel.
So, write it down. That's it for subtraction. So let's check what we've done. We looked at quick ways of doing subtraction in our heads and how to write down more difficult subtraction. We saw how to use a calculator to do subtraction, and we looked at some problems involving subtraction. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the program again. There are also books, a maths audio tape, and our interactive Revisewise website to help you make the most of what you know when you're preparing for your test. So we'll let you get on with your test, and you get on with your television revision.
The next program is about multiplication.
In this unit, we're looking at multiplication to help you make the most of what you know when you come to do your Key Stage 2 maths tests.
What's the best way to work this question out? It says, calculate 58 times 6.
That's multiplication, all right. Multiplying numbers is something we do a lot in maths, so over to our maths team to remind us what it means.
Multiply is the same as times. It also means product.
It also means lots of.
It also means groups of.
It also means sets of. And it also means repeated addition.
In everyday life, we're often multiplying numbers.
When you buy a few of the same thing, you can do the multiplication in your head.
They're 35p each, so how much are 3? Well, 35 times 3 is 105, so that must mean they're £1.5. So those are 6 bottles, which are all 39p, so 39 times 6.
When you buy more of the same thing, write the prices down to multiply them.
£2.34.
246 times 39.
Another way to multiply the price of several things is to use a calculator.
It's 234.
Now, when you're faced with some numbers you want to multiply, it's useful to think first, can I do it in my head? Do I need to write it down? Or should I use a calculator? Let's look at how to do multiplication in our head. That's mental multiplication. The secret is to know your multiplication number facts, otherwise known as your times tables.
1 times 4 is 4, 2 times 4 is 8.
3 times 5 is 15. 4 times 5 is
20.
6 times 6 is 36.
7 times 8 is 56.
9 times 9 is 81, and 10 times 9 is 90.
Once you're sure about your tables, you can use them to help with any multiplication problem. Have a look at this one. What's 40 times 70? Well, we know from our times tables that 4 times 7 is 28. 4 times 70 is going to be 10 times bigger. So that's 280. 40 times 70 is going to be another 10 times bigger. That's 2,800. The trick is to multiply the significant digits and then make sure you get the place value right by having the same number of zeros in your answer. Try this one. 400 times 700. 4 times 7 is 28, and there are 4 zeros. So we need 4 zeros in the answer, turning the 28 into 280,000. Let's get our maths team to have a go at the question. 58 times 6. Can you do it before they do?
This is how I would work out 58 times 6. I'd do 50 times 6 is 300, then 8 times 6 is 48, and add it together, which would equal 348.
This is how I would work out 58 times 6. I would do 10 times 58, which was 580. Then I would half that to 290. Then I'd do 1 times 58, and then I'd add them together for 348.
Although they used different methods to get the right answer, they both changed the sum into something easier that they could work out first. So that should help you answer your question.
It certainly does. I split the 58 into 50 and 8. 50 times 6 is 300, and 8 times 6 is 48. So I add them together to get 348.
That's right. Whichever way you use, it's really worth practicing mental multiplication with friends or at home.
7 times 9.
63. 60 times 4.
240. 800 times 6.
4,800.
Here's another multiplication question, but it's got a digit missing.
Missing digit questions like this often come up in tests, and they can seem tricky to work out. Just keep your wits about you and use what you know to get the answer. Try this one. 50-something times 8 equals 456. Let's ignore the missing digit for now and do 50 times 8, which is 400. That leaves us 56 short of the right answer. So we look for something that multiplies by 8 to give 56. Seven times 8 is 56, so the missing digit is 7.
OK, so I ignore the missing digit for now and do 7 times 9, which is 63. But that leaves me 270 short of the right answer. So I look for something to multiply by 9 to give 270. Thirty times 9 is 270, so the missing digit is 3.
So write it in the box.
What about this question? 11 looks a bit harder. I'm not sure I can do it in my head.
OK. When the multiplication is too difficult to calculate in your head, use written methods, like our maths team.
This is how I would work out 738 times 46. I would break up the 46 to 738 times 20, which would equal 14,760. Then I'd do 738 times 20 again, which equaled the same answer. So that was 40 times. Then I'll do 738 times 3, which equals 2,214. Then I'll do 738 times 3 again, which equaled the same. So that was 46 altogether. Then I'd add up all these answers. 40. And the answer would be 33,948.
Here's another method.
This sum is 738 times 46. I'm splitting up the numbers so that it still makes the same number. 40 times 700, but I'm going to take away the zeros, which equals 28, and add on 3 zeros. Then I'm going to do 40 times 30, which equals 1,200. Then I'm going to do 40 times 8, which is 320. Add those all together and it equals 29,520. I'm going to do 6 times 700, which equals 4,200. 6 times 30 equals 180. 6 times 8 equals 48. Add those all together and it equals 4,428. Add those all together and it equals the answer is 33,948.
With a big sum like this, there are lots of chances of making a mistake. So it's a good idea to make an estimate of roughly what the answer ought to be. So does that help answer your question?
Yes, I'll write the sum out.
But don't forget to do an estimate first.
Ah, yes. How about turning 431 times 23 into 400 times 25? 4 times 25 is 100, with 2 more zeros. That makes 10,000.
OK, so now do the sum.
431 times 3 is 1,293. 431 times 20 is 8,620, and you add them up, to get 9,913.
And how does that match your estimate?
Well, 9,913 is pretty close to 10,000, so I'd say my answer is probably right.
Don't forget the third way of multiplying numbers, using a calculator. It's tempting to think that because they're electronic, they're always right. Wrong. The answer a calculator gives depends on what you tell it when you press the keys.
Here's a question that looks as though it's about multiplication, and it's on paper B, so I can use the calculator to do it.
Go on then.
2,753 people go to a sports event. Each person pays £2.30 for a ticket. What is the total amount of ticket money collected?
That's a good one. There are lots of questions about real-life situations like this on the test papers. The first thing to work out is what maths to use.
So I multiply 2,753 by 2.30 and it equals 6,331.9. So that's the answer.
Now, is it? Remember the trap you can fall into when working out money calculations on a calculator?
Ah, of course. The answer should be in pounds and pence. So I have to write £6,331 90p.
That's right. Well, that's the end of our unit on multiplication. So let's check what we've done. We did some mental multiplication using known number facts to help us. We looked at ways of doing written multiplication with bigger numbers and saw how important it was to estimate the answer first. We used a calculator to multiply. And we looked at some real-life multiplication problems. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the programme again. There are also books, a maths audio tape, and our interactive Revisewise website to help you prepare.
The next programme is about division.
In this programme, to help you with your Key Stage 2 maths tests, we're going to take a look at division. Now, can you see any questions about division in your test paper?
Yes, here's one. It says, 2 of these numbers divide by 5 with no remainder. Circle the 2 numbers.
That's a good one to start with, and it shows what a close link there is between division and multiplication. If you know your multiplication tables, then you can do division as well. Back to your question, are any of these numbers in the 5 times table?
Let's see. 5 times 5 equals 25, and 5 times 12 equals 60.
That's right. It's really useful to know your divisibility rules. That's things like a number is divisible by 5 if it ends in 5 or 0. And the maths team have got some more examples.
A number is divisible by 10 if it ends in a naught. A number is divisible by 2 if the last digit is even. A number is divisible by 3 if the sum of all the digits is divisible by 3. A number is divisible by 9 if the sum of all the digits is divisible by 9.
When we talk about division, there are lots of different ways of saying it. So, back to the maths team.
Division means share equally. It also means group equally.
It also means divide by. It also means repeated subtraction.
When you're faced with numbers you want to divide, it's useful to think first. Can I do it in my head? Do I need to write it down? Or should I use a calculator?
Here's another division question. This time it's got a missing number. It says something divided by 5 equals 22.
And I think you can do this one in your head. With division like this, you can use what you know about multiplication to work out the answer. We're looking for something divided by 5 that gives us 22. Well, there's a big something, divided into 5 parts, and each of them is worth 22. So the something we're looking for equals 22 plus 22 plus 22 plus 22 plus 22. That's 5 times 22 equals 110. So 110 divided by 5 equals 22.
So I write 110 in the box.
See how multiplication and division are related to each other. 5 times 22 equals 110. 110 divided by 5 equals 22. And 110 divided by 22 equals 5. Once the numbers get bigger, it gets too difficult to do the division in your head, and you'll have to write it down. Let's try a difficult one, like 972 divided by 36. And with something like this, it's important to make an estimate first of roughly what the answer should be. See if the maths team can do it.
This is how I would work out 972 divided by 36. First I would make an estimate, and that I would make 972 to 1,000, make 36 to 40, and 1,000 divided by 40 is 25. So then I would do 36 times 10 equals 360. Then 36 times 10 again, which equals the same. Then I would try 36 times 5, which is half of 10 times, so that would be 180. Then altogether, these 3 answers add up to 900, so there's 72 left, which would be 36 times 2 equals 72. So altogether, that equals, which equals 27, so my estimate was about right.
See how Nicola made an estimate first, rounding the 972 up to 1,000 and the 36 up to 40. Then she did 1,000 divided by 40 to get her rough estimate of 25. Then she broke this difficult problem down into easier sections. Nicola knew that 36 times 10 is 360. Take that away from the 972 to get 612. 36 times 10 again is another 360. Take that away from the 612 to get 252. Next, she did 36 times 5, which she knew is half of 36 times 10, and that's 180. Take 180 from the 252 to get 72. And Nicola knew that 72 is 36 times 2. So altogether, she got 27 36s. So the answer to how many 36s in 972 is 27, which is close to the estimate of 25. Let's try something a bit easier. 972 divided by 6. We'll go through it carefully, step at a time. The nearest number of times that 6 will go into 9 is 1. 1 times 6 is 6. 6 from 9 is 3, bring down the 72. The nearest number of 6s into 37 is 6. 6 times 6 is 36. 36 from 37 is 1, bring down the 2. 6s into 12 is 2. 2 times 6 is 12. 12 from 12 is 0. So the answer is exactly 162. The important thing is to make sure everything is lined up properly, with the units above each other, the tens above each other, and so on. If one number divides into another exactly, the answer comes out as a nice whole number. But what do you do if something doesn't divide exactly? Well, there are 3 ways you can give the answer. with a whole number remainder left over, as a fraction, or as a decimal. And let's have a go at 46 divided by 5 each of these ways. You can have a go at this.
Well, I know that 45 divided by 5 is 9, so 46 divided by 5 is 9 remainder 1.
That's right. Let's see what the answer is as a fraction. There's another way of looking at the remainder 1 left over, and that's to ask 1 what left over. And because you're dividing by 5, this remainder left over is 1/5. So 46 divided by 5 is 9 and 1/5. What's the answer as a decimal? 46 divided by 5. Well, the nearest 5 into 46 is 9. 9 times 5 is 45. 45 from 46 is 1. Add a 0 after the decimal point so we can carry on and bring it down. 5 into 1.0 is 0.2. 0.2 times 5 is 1. 1 from 1 is 0, so that's it. 46 divided by 5 is 9.2. So 46 divided by 5 is either 9 remainder 1, 9 and 1/5, or 9.2. In the test, you'll often get questions about real-life situations, testing if you can work out what to do with the remainder of a division sum. Try this. A cinema ticket costs £5. How many tickets can I buy for £46?
That's easy. You just divide 46 by 5.
Well, that's right, but then what do you get?
9.2, or 9 and 1/5.
Those are answers to 46 divided by 5, but you can't buy 0.2 of a ticket or 1/5 of a ticket. Let the maths team have a go.
First I do 46 divided by 5, which equals 9 remainder 1. I have to round that down to 9 because I haven't got enough money to buy another ticket.
So Keely had to round the answer down for it to make sense. She couldn't buy a fraction of a ticket, so she had to settle for 9 tickets and have £1 left over. Now try this question. There are 46 children in the dining hall. Each table seats 5. How many tables do I need to seat all the children?
That's 46 divided by 5 again.
Well, that's right. So, back to the maths team.
So first you would do 46 divided by 5, which will be 9 remainder 1. You would need 9 tables, but then you need to round up to 10 tables for that one child left over, so altogether you would need 10 tables.
So Nicola had to round the answer up for it to make sense. She couldn't sit a fraction of a child at each table, so the one child left over needed a whole table to sit at. With division problems like these, you have to check exactly what the question is asking you and then give an answer that makes sense.
Here's one in this test paper. It says there are 70 children camping. Each tent takes up to 6 children. What is the least number of tents they will need?
Off you go then.
Well, I need to divide the total number of children by the number of children each tent can hold, and that will give me the number of tents.
Yes.
That's 70 divided by 6. 11 times 6 equals 66. So the answer is 11 remainder 4.
But what do you do with the remainder?
Well, the remainder is 4 children, and they need a whole tent. So I have to round the answer up to 12.
So write the answer in the box for 2 marks. Don't forget to show your workings out in the box. If you get an answer wrong, but your working is right, you'll get a mark. Now the third way of dividing numbers, using a calculator. Don't forget, the answer a calculator gives you depends on what you tell it when you press the keys. So it's really important to do an estimate first to check the calculator's answer.
My sum is £332 divided by 8. I'll divide my £332 to £320 divided by 8, which would be about 40. Now to make sure my calculator is clear, then I'd have to type in 332 divided by 8 and equals, which is 41.5. But because it's money, I'd have to say it's £41.50.
So whatever your calculator gives, when you're doing a money problem, always give the answer to 2 decimal places to get the number of pence right. That's the end of our program on division. So let's check what we've done. We did some mental division using what we know about multiplication to help us out. We looked at ways of doing written division with bigger numbers and saw how important it was to estimate the answer first. We looked at some real-life division problems where you have to work out what to do with the remainder. And we used a calculator to do division, being careful to make sense of the answers it gave us. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the program again. There are also books, a maths audio tape, and our interactive Revisewise website to help you prepare.
The next program is about how to use a calculator.
In this program, to help you with your Key Stage 2 maths tests, we're going to look in more detail at how to use the calculator.
Well, I'm ready. I've got my test paper, my pencil, my ruler, and my calculator.
Can I just check something? That's okay, it's test paper B. Remember, when you come to do your tests in May, there are 3 maths papers altogether. There's a short mental maths paper and 2 written papers, paper A and paper B. And it's only in paper B that you can use a calculator. So what's the day of the paper B test like?
This morning it's test paper B, mathematics. On test paper B, you are allowed to use a calculator. Everyone should have a calculator on their table at the moment. Could you just check that it works? Work as quickly and as carefully as you can. You have 45 minutes for this test. You may begin.
In paper B, it's up to you to decide when your calculator will help you get the answer. And if you're going to use your calculator in the test, it's important to know how to use it properly.
Using a calculator seems really easy. Because it's electronic, it's tempting to think that whatever answer it gives, it must be right. Wrong. The answer a calculator gives you depends on what you tell it when you press the keys. If you tell it the wrong thing, by pressing the wrong keys, for example, it will tell you the wrong thing. So make an estimate first. Let's try 2,593 plus 6,078. Make an estimate first. It's a bit more than 2,500 plus 6,000, which is 8,500. Now we can see what the calculator comes up with. First, press the clear key to get rid of any calculations that might be in the calculator already. Then press 2593 plus 6078 equals 8,671, which is close to my estimate of 8,500. Over to our maths team to do some more with their calculators. This time, multiplication. Try 472 times 93. First, let's do an estimate, say 450 times 100, which is 45,000.
Just going to check if my calculator is clear. My sum is 472 times 93, so I have to enter 472 and I press times 93 plus the equal sign, and my answer is 43,896.
And that's pretty close to our estimate of 45,000. Here's some division. Try 293 divided by 8 to 2 decimal places.
I'd round 293 to 300 and 8 up to 10, which should give me an answer around about 30. So make sure our calculator's clear and enter 293 divided by 8, which equals 36.625. Rounded to 2 decimal places would be 36.63.
Which is pretty close to his estimate of 30. Notice how the calculator gave the answer to 3 decimal places, so Glenn had to round it down to the 2 decimal places he wanted. A calculator will give the answer to as many or as few decimal places as it needs to, and this can cause problems when you're doing division, especially calculations involving money.
My sum is £332 divided by 8. Now to make sure my calculator is clear, then I'd have to type in 332 divided by 8 and equals, which is 41.5. But because it's money, I'd have to say it's £41.50.
So whatever your calculator gives, when you're doing a money problem, always give the answer to 2 decimal places to get the number of pence right. A normal school calculator can only give an answer as a whole number or a decimal number. It can't give the answer as a fraction or a whole number with a remainder. If you want the answer as a fraction, it's useful to know the equivalent decimal. Over to the maths team.
A half is equivalent to 0.5.
1 quarter is equivalent to 0.25.
3/4 is equivalent to 0.75.
1/10 is equivalent to 0.1.
2/10 is equivalent to 0.2.
3/10 is equivalent to 0.3.
In fact, you can use your calculator to work out the decimal equivalent of a fraction. Think of the fraction as a division sum. So 1/4 is 1 divided by 4, and do it on your calculator. So 1 divided by 4 equals 0.25. Here's something to watch out for. Try 10 divided by 3 using the calculator.
So I've put in 10 divided by 3 and equals 3.33333, which I know is a recurring decimal. I know this is equivalent to a third.
Now the calculator gives the number of decimal places it feels like. In this case, the 0.3333 would go on forever. It's called a recurring decimal. But we know that 0.3 recurring is the same as 1/3. How about 20 divided by 3?
20 divided by 3. I press the equals. And the answer is 6.66666666. I know this is a recurring decimal, and I also know that it's equivalent to 2/3.
Here's another strange thing. Multiply 0.3333 by 3. We know that this is the same as multiplying 1/3 by 3. So, what should we get?
I'm going to multiply 0.33333
by 3. So I'll press times 3, which gives me an answer of 0.999999, which I know is equivalent to 3/3, which also means 1.
So when you're using your calculator to do division, watch out for these recurring decimals. 0.3 recurring is the calculator's way of telling you that the answer is 1/3. 0.6 recurring is the same as 2/3. And 0.9 recurring is the same as 3/3. That's 1. The calculator will always give you an answer, but only you can decide if it's right. There are some buttons on the calculator that can help you if you know how to use them properly. They're the memory buttons, and you can use them to save parts of your calculation as you go along. Look at this. What is 2 times 3 in brackets plus 6 times 8 in brackets? Now, we could do this in our head and jot things down as we go. The 2 times 3 in brackets is 6, and the 6 times 8 in the other brackets is 48. Add them together is 54. Now, how can you do this on the calculator?
My sum is 2 times 3 add 6 times 8, and I have to put that into the memory. So what I have to do is I have to type in 2 times 3 memory add. Then I've got a memory sign up the top. Then I'd do 6 times 8 memory add. Then I'd have to press memory recall for my answer. My answer is 54.
So what Kelly did was to put the answer to the first part of the calculation, the 6, into the calculator's memory, while she did the other part. Then she added the second part of the calculation, the 48, into the memory. Now, in the memory, it joined up with the 6 already there to make 54. And that was a fairly simple calculation that maybe didn't need a calculator to do it. But something like this certainly would. The great thing about a calculator is that it doesn't mind whether the numbers are easy or difficult, large or small. It just gets on and calculates. Calculators are such useful things, it's tempting to use them to do all your maths. Now, that could be a mistake, because some things are quicker and easier to do in your head. Try 59 add 43.
Can Nicola beat the calculator?
To find the answer to 59 add 43, I'd turn the 59 to a 60, then at the end take away 1, and the answer would be 102.
Nicola won.
But in your paper B test, once the numbers get bigger or more difficult, it's time to use a calculator. Let's try a test question.
Here's a question that looks as if I should use the calculator to do it.
Go on then.
Let's see, it says 2,753 people go to a sports event. Each person pays £2.30 for a ticket. What is the total amount of ticket money collected?
That's a good one. There are lots of questions on the test papers about real-life situations like this. And whether you're going to use a calculator or not, the first thing you have to do is work out what maths to use.
So, if 2,753 people pay £2.30 each, I need to multiply 2,753 by £2.30.
Don't forget to do an estimate first.
Right, so that's roughly 3,000 multiplied by 2, so that's about 6,000.
So do it then.
So I multiply 2,753 by 2.30, and it equals 6,331.9. So that's the answer.
Now, is it? Remember the trap you can fall into when working out money calculations on a calculator?
Ah, of course. The answer should be in pounds and pence. So I have to write £6,331.90p.
That's right. Another way the calculator is useful is that it can do calculations very quickly. So you can try things out, like in this question.
The same number is missing from each box, but the same missing number in each box. Then it's got something times something times something equals 1,331.
You could use your calculator to try out a few numbers.
Well, I know that 10 times 10 times 10 equals 1,000, so let's try 11 times 11 times 11 equals, aha, that's it, 1,331.
So what do you write down?
11 in each box.
That's the end of our program on using the calculator. So what have we done? We saw how you can only use your calculator in Maths Paper B. We reminded ourselves how to use the calculator keys properly and how to make an estimate first. We saw how to make sense of the answer your calculator gives you and how to decide when to use your calculator and when not to. You and your teacher can go over these things at school. And don't forget, you can always wind the tape back and look at bits of the program again. There are also books, a maths audio tape, and our interactive Revisewise website to help you make the most of what you know when you're preparing for your test. So we'll let you get on with your test and you get on with your television revision.